Welcome back to Harbour Unboxed. Today, we're reviewing a $5,000 US CPU. But don't worry, we have a more affordable $2,500 US option as well, so this should be fun. Obviously, these aren't mainstream CPUs. They are part of AMD's latest high-end desktop lineup, and boy oh boy are they powerful. But before we get into it, today's sponsor spot is brought to you by Antec and their Performance One Full Tower E80X case. Designed to support the latest RTX 40 series graphics cards up to 400mm long, the P1 is big on the inside with loads of options for top and front mounted radiators, including the ability to support dual 360mm radiators simultaneously. The P1 comes with 4 pre-installed Storm T3 PWM fans, with the ability to expand fan support to an additional 6. It includes a temperature display, dual 4mm tempered glass side panels, cable management covers complete with Velcro straps for quick and easy cable management, and now also comes in a very clean white version. Exclusive to Amazon US, there are some excellent Black Friday discounts of up to 20% between the 20th and 24th of November. So for more information, please check the links in the video description. Okay, so what we have here is the new Ryzen Threadripper 7980X and 7970X, packing 64 and 32 cores. There's also the 7960X offering 24 cores for $1,500 US, but unfortunately we weren't able to get that model in time for the release. Now, the Threadripper 7000 series, it's a bit more complex than past Threadripper series, as it's essentially split into 2 platforms. As I noted earlier, we are looking at the HEDT parts, but there's also the Pro series offering up to 96 cores, more PCIe lanes, and more memory channels, with the obvious catch being that they cost, well, a lot more money. But rather than delve into all 6 Pro models, which we won't be testing today, I'll quickly show you the specifications while we talk about the models we will be testing. Now, it's worth noting that the Threadripper 7000 series has moved to a 4844-pin STR5 socket and is in no way compatible with the 4094-pin SWRX8 socket used by the previous Threadripper 5000 series. There are also 2 STR5 chipsets, the WRX90 and TRX50. The WRX90 chipset, that supports the Pro CPUs and the Pro CPUs only, while the TRX50 chipset supports both Pro and HEDT parts. And as noted earlier, the key difference is PCIe lane count and memory channels. If you use a Pro CPU on a WRX90 motherboard, you will have 144 usable PCIe lanes and octa-channel memory support. But if you install a Pro CPU on a cheaper TRX50 board, you will be limited to 88 usable PCIe lanes and quad-channel memory. Speaking of memory, Threadripper 7000 series processors can accommodate up to 8 memory channels with 2TB of memory on a WRX90 motherboard using 256GB DIMMs, or up to 4 channels for 1TB of memory on a TRX50 motherboard. Both platforms do officially support DDR5 5200 in either single or dual rank configurations. Though it's not your typical DDR5 memory that's supported here, both platforms use registered DIMMs, so you will require DDR5 RDIMM, LRDIMM, or 3DS RDIMM. It's worth noting that the RDIMMs are not compatible with conventional unbuffered or unregistered memory, the sort of memory used by AM5 processors, for example. So for testing, AMD has provided us with a 128GB kit of G-Skill's Zeta R5 Neo DDR5 6400 RDIMM memory. These are 32GB modules, and while I don't have the exact price for them, they're going to be very expensive, as 8-stick 128GB kits cost $1,000 US. Realistically for now though, you're only going to be using up to 256GB of memory with one of these Threadripper HEDT parts on a TRX50 motherboard, given that all currently available models only offer 4 DIMMs. And 128GB registered DDR5 modules are quite expensive at around $1,000 US for a DDR5 4800 spec kit. And if you want a 512GB kit, you'll be looking at over $5,000 US right now, so good luck with that. Now the CPUs we'll be testing are the 7980X and 7970X, so let's quickly touch on those parts. The Threadripper 7980X comes in at $5,000 US. It offers 64 cores with 128 threads using 8 CCDs and a single I/O die. In total, it packs 256 megabytes of L3 cache, 48 PCIe 5.0 lanes, and 4 memory channels. The cores run at a base clock of 3.2 GHz with a 5.1 GHz boost. And like all Threadripper 7000 series parts, the TDP has been set at 350 watts. Then we have the Threadripper 7970X, which is essentially a cut down model. It's cut in half basically, with just 4 CCDs, giving it 32 cores and 64 threads with 128 megabytes of L3 cache. And as a result, the price has also been cut in half to $2,500 US. But because the TDP remains the same at 350 watts, the base clocks have been dramatically increased to 4 GHz, and we even see a slight increase in the boost clocks, hitting 5.3 GHz. There's also the 7960X, which, as I said earlier, we don't have, but it's the 24-core 48-thread model, which will sell for $1,500 US. So that's the Threadripper 7000 series HEDT lineup. Now it's time to go over the test system specs and then, of course, jump into the results. For testing, we're using the Asus Pro WS TRX50 Sage Wi-Fi motherboard, 128GB of DDR5 6400 CL32 memory, and the GeForce RTX 4090. Then for cooling, AMD did provide the NZXT Kraken 360, but they failed to include the mounting gear in the box. So last minute we had to get our hands on something else for testing, and that something was the Deepcool LT520, a 240mm AIO, so not a 360mm model, but it had the mounting gear we required. Finally, we tested using the latest build of Windows 11 with all drivers up to date, so let's get into it. Starting with the Cinebench multi-core test, we find the 7980X is 28% faster than its predecessor, the 5995WX. Meanwhile, the 7970X was just 15% slower, so not bad given it packs half as many cores. And not only that, but when compared to the 3970X, which is a 32-core part using Zen 2 cores, it was an impressive 67% faster. Sadly, I don't have any competing Intel workstation processors for comparison, though it's my understanding that the latest 56-core flagship Xeon model performs similarly to that of the 5995WX in this test. What's really impressive here though is that for roughly the same power usage, the 7980X was 150% faster than the Core i9-14900K. Where the Threadripper CPUs aren't all that impressive is single core performance. Obviously 32 and 64 core processors aren't going to shine here when compared to higher clocked mainstream alternatives, but still the 7970X was 36% faster than the 5995WX, while the 7980X was 32% faster. So the Zen 4 based Threadripper CPUs are much faster when compared to the older Zen 3 models, as you'd probably expect, but still, over 30%, that's a big improvement. The Blender Open Data results are similar to what we saw in the Cinebench multi-core test. The 7980X, for example, that was 41% faster than the 5995WX, which is a super impressive result, and it meant that the 7970X was just 13% slower than the previous generation 64-core part. Next up, we have the 7-zip compression test, and here the 7980X was almost 40% faster than the 5995WX, so another very impressive result here. In fact, even the 7970X was faster than the 5995WX, besting it by a 7% margin, which meant the 7980X was just 30% faster than the 32-core model. The 7-zip decompression performance is even more impressive when looking at AMD's new 64-core HEDT part. Here the 7980X was 62% faster than the 7970X and 45% faster than the 5995WX. Now, when it comes to applications such as Adobe After Effects, which are more lightly threaded, the core-heavy Threadripper CPUs, they're not that impressive. And although performance is hardly weak, it's just not representative of their true performance, as much of the CPU does go unused. Still, when compared to the 5995WX, we're looking at around a 15% performance bump with these newer models. Photoshop's even worse at utilizing these core-heavy CPUs, and for the most part will tax just a single core, and for that reason the Threadripper parts don't score particularly well here, and certainly don't justify their asking price. Basically, if you're looking to primarily use lightly threaded applications, you wouldn't be in the market for a Threadripper CPU. Premiere is a little more core heavy, though it depends heavily on the workload. In the Puget Systems benchmark, we see that for general editing, the 7980X and 7970X are better than the standard desktop Zen 4 parts, but they're not that much better. And the last application test we have is a browser benchmark, so more of a general usage type test, and here the new Threadripper parts are comparable with that of standard desktop processors because unsurprisingly, web browsing is a lightly threaded task. Okay, time for a brief look at some gaming performance, which really isn't the focus of these Threadripper parts, but hey, maybe you also want to game on your workstation PC, so we'll start with Baldur's Gate 3. And we see that both Threadripper 7000 series parts are slightly slower than the slowest AM5 Zen 4 processor, the Ryzen 5 7600X. So we're certainly looking at highly playable performance, but it's no 14900K or 3D Vcache part. And given how many cores these parts pack, the total system consumption when playing Baldur's Gate 3 is quite impressive. Still, efficiency is not amazing given that we're looking at comparable performance to that of the 7600X for a 22% increase in total system usage. The Threadripper performance in Cyberpunk 2077 Phantom Liberty wasn't great. Sure, it was highly playable, but with just 120 FPS on average, they were about 14% slower than the 7600X. Still, the 7980X was 23% faster than the 5995WX, so that's a nice improvement. And something I should mention is that the Zen 4 cores are very memory sensitive, and the AM5 processors are using low latency DDR5 6000 CL30 memory, whereas the Threadripper 7000 series has to use RDIMMs, and AMD provided DDR5 6400 CL32 memory, which runs at more relaxed secondary and tertiary timings, and this will negatively impact FPS performance in certain titles. Again though, power consumption's not bad, despite the somewhat weak FPS performance. When compared to the Intel Core i7 and Core i9 parts, these 32 and 64 core monsters don't look that outrageous. Spider-Man Remastered plays really well on the 7970X and 7980X, both delivering around 7700X to 7600X levels of performance. The 64 core part was 14% faster than the 5995WX, so a nice little boost there. That said, you do pay for the extra performance in the form of power usage, as the 7980X managed to outpower even the 14900K, and that's no easy feat, even for a 64 core processor. Next up, we have Assassin's Creed Mirage, and here performance is much lower than you might expect, with the 7980X coming in 16% slower than the 7600X, though it was 23% faster than the 5995WX, so by Threadripper standards, that's a pretty good result. Again, power efficiency when gaming is quite poor, with the 7980X pushing total system usage almost as high as the 14900K, despite being 22% slower. The Watch Dogs Legion performance is more what you'd expect based on the 7600X result. Essentially, we're looking at Zen 4 Ryzen 5 performance with 146 to 148 FPS on average, which is a 24% improvement over the older 5995WX. Unfortunately, when compared to the 7600X, total system consumption has increased by 33%. So the 7980X isn't the most efficient gaming processor, but then it's not really a gaming processor at all, so probably not a big deal. Finally, we have Hitman 3, and again, the 7980X and 7970X can't even match the 7600X, trailing by a 10% margin. And this is almost certainly down to the difference in memory use between the Threadripper and AM5 processors, but it's not an issue as Threadripper isn't designed for gaming, rather these are core-heavy productivity processors, but as I said earlier, you may still want to know how well they can game because, well, you might want to game on your workstation PC from time to time. And lastly, here's a look at total system power usage while playing Hitman, and as you can see, the 32 core and 64 core processors aren't the most efficient for gaming. Who knew? Now it's time for a look at operating temperatures, and again we are using the Deepcool LT520, a 240mm all-in-one liquid cooler. And starting with the 7970X running an all-core workload in Cinebench, after an hour the system hit a peak hotspot temperature of 88 degrees on the cores, and sustained a core clock frequency of 4.6 GHz, so a great result using a modest cooler. Then installing the 7980X, we ran the same test under the same conditions and found an average clock frequency of 4.1 GHz with a peak hotspot temperature of just 85 degrees. So another great result there, and it means keeping these new 32 and 64 core Threadripper CPUs cool is a relatively easy task. Now time for some overclocking, as these processors are unlocked, though we're just going to enable PBO via Ryzen Master and Windows to see what that does. Both CPUs saw around a 7% performance boost in Cinebench with PBO enabled, so that's pretty good, though it is far from free performance. With the 7980X, total system power usage increased by 26%, and we saw a 19% increase with the 7970X, so I can't say I recommend overclocking these workstation processors. Okay, so something I want to talk about is my experience with the Threadripper 5000 series, namely the 7990X, which I am sad to say it wasn't very good, but let me explain. I've been using Threadripper CPUs in my main PC for years now. In fact, it all started with the 1950X, which at the time was a godsend for editing videos. That CPU though was quickly replaced with the 2950X, which was even more impressive, offering slightly better performance while addressing the weak memory support of the 1950X, and best of all, was supported on the same X399 motherboards, so that made for a quick, easy, and cost-effective upgrade. I skipped the 24 and 32 core models of the Threadripper 2000 series, as the janky 4CCD design didn't work that well, so I wasn't impressed with the 2970WX or 2990WX. After that, Tim and myself migrated to the 3970X for our editing PCs, and again, the experience here was excellent, though I wasn't impressed that AMD dropped compatibility for this series, basically screwing over Threadripper 1000 and 2000 series customers by moving the 3000 series to the TRX 40 chipset, and it gets even worse because the 3000 series were the only CPU series to work with TRX 40 boards. Still, it was also nice to finally move to 32 cores without having to deal with the janky core configurations of the previous generation. The 3000 series did also offer a 64 core model, but at $4,000 US each, we weren't able to wrangle one of those for our editing PCs. Then there was the Threadripper 5000 series, the Zen 3 based models, which once again required a new motherboard and were in no way compatible with boards that came before them. That means if you invested big money in a TRX 40 board, which you almost certainly would have, you needed to do it all over again with a WRX 80 board to support 5000 series processors. Still, when I first got my hands on the 5995WX, I was blown away by the performance. Sure, it cost $6,500 US, but for work, the 64 core monster was worth it, or at least I thought it was. I'll try to make this story as brief as possible as it spans over 12 months of troubleshooting. Initially though, all went well. I was using the MSI WS WRX80 motherboard, and that was the same motherboard I used to review the 5995WX. For roughly 6 months, all was well. It was a dream to use for editing our videos, with encoding performance that was blistering fast, but then it all slowly started to go a bit sideways. First, it was just the little stuff, but very annoying stuff. For example, the chipset fan would ramp up to max speed randomly. It would just do this over and over again, and there was no way of adjusting it. So we removed it and installed a new fan that we could control via an onboard fan header. Then the VRM fans, they started doing basically the same thing, randomly spinning up to maximum speed. It was very unpleasant, very annoying, and again, there was no fix, so we removed the fans. Shortly after that though, MSI did swap the board out for a new model, and quite bizarrely, that board wouldn't post, and still doesn't to this day, using GeForce GPUs, forcing us to use Radeon, which was fine, as I was using a 6900 XT anyway, but it was an issue further down the track when we started troubleshooting performance-related issues. On that note, before long, the fans were the least of our worries. The system started randomly crashing when using Premiere, which we initially chalked up to an Adobe-related issue, but found that my older 3970X system, which I still had, that worked just fine. We also noticed that the 5995WX was not nearly as fast as when I first reviewed it, and after several fresh Windows installs and a lot of head scratching, we never worked out what was going on. At the time, I was working with both AMD and MSI to solve the various issues we were facing, and we made no real progress. I also couldn't work out why MSI had not issued a single BIOS release since announcing the WS WRX80 motherboard, And after quizzing my local contact, we learnt that the WS-WRX80 motherboard never even entered production. Apparently demand was so low that MSI never bothered to make the board, beyond the handful of samples that were sent out to media. And I only learnt this about a year after using the board and trying to work out why none of the issues I'd been having had been addressed. So, having learnt that I was using an unsupported product, AMD agreed to swap out the 7970WX processor for a brand new one, just in case there was an issue with our CPU, and we also received the ASUS WRX80E Sage SE Wi-Fi motherboard, a WRX80 motherboard that was actually being manufactured and sold. So, a very long story short, and believe me, this is the very cut down version of this story, I got the new CPU and motherboard, installed them in our workstation, set it all up, and things seemed pretty good, though never quite as good as the 5995WX was originally. Performance was, I think it's fair to say, inconsistent. Sometimes encoding videos was really quick, while other times it took several times longer than it should have, and despite never crashing, it just didn't seem right. In the end, we had to give up on the 5995WX. It let us down too many times. It was a huge disappointment. The solution was to build two 7950X 3D workstations, one for me and one for our video editor, and we've been using them for almost a year now, and the experience has been flawless. I will move Balin over to the 7980X, and we'll see how that goes, but this has caused me to have some reservations in regards to AMD's Threadripper platform, especially if we were a paying customer. That said, this is by no means an AMD-only problem, it's more of an HEDT problem, but put simply, not enough people buy pro-grade hardware, and therefore support can be lacking, certainly when compared to the mainstream offerings. For example, years ago, I was using Intel HED processors, and it was often a bit of a mess with silly stuff like USB issues and then more serious stuff like crashing. That said though, the 5995WX experience has been one of my worst to date, if not my worst. So I guess my biggest issue with the Threadripper 7000 series so far is the limited compatibility. Of course, with Zen 4 we are moving to DDR5, so it makes sense that there would be no backwards compatibility with prior series, or that you can't use something like a 7980X, for example, on a WRX80 motherboard. My concern rather is for future Threadripper releases. I don't expect that the 8000 series will work on TRX 50 boards, and AMD certainly hasn't made any such claims. So be aware of that, but as much as I hate how much of a mess Threadripper compatibility has become, it is less of an enthusiast platform now, and even these non-pro models are very much serious workstation CPUs. And really, it was always going to head in this direction, with mainstream parts such as the Ryzen 9 7950X now offering 16 cores and 32 threads for under $600 US. Truth be told, for most users, modern Ryzen 9 and Core i9 processors are more than powerful enough for most tasks, even 4K video editing, and that leaves Threadripper as more of a specialty item. As a side note, the Intel competition to a part like the 7980X would be the Xeon W9 3495X, a CPU that unfortunately we can't get our hands on, though it does cost a cool $6,700 US at retail. It's a 56-core processor that scores around 64,000 points in Cinebench R23, so slightly less than that of the old 5995WX, making the new 7980X almost 50% faster. That being the case, these new Threadripper 7000 series processors have no competition, so if you're in need of a core-heavy processor and/or require a lot of PCIe lanes, there's really no better alternative. Finally, we plan to replace one of our 7950X 3D editing PCs with the 7980X, so we'll be using that daily from this point forward, and I'll let you guys know how that works out. Fingers crossed it does much better than the 5995WX and is much more like my 3970X experience. And that is going to do it for this video. If you liked it, you know what to do. Subscribe for more content. We also have Floatplane Patreon if you want to become a Hardware Unboxed community member, get access to our exclusive Discord server for members only, monthly live stream, Q&A stuff, and behind the scenes content. So check that out if you're interested, but if not, that is perfectly fine. And I would of course like to thank you for watching this video. I'm your host Steve. See you next time.